Hello, thanks for coming to a mobile-first approach to 3DSecure today. This talk is about security and how to design secure architecture mostly, and also about how to design secure architecture and find the balance with mobile-first approach. So everything is, we're trying to simplify user experience, but we need to still take care about the security. First, I will introduce myself. My name is Alina Denisenko. I'm working as a senior software engineer at N26. I have about 7 years experience as backend engineer and 5 years experience in fintech. This is like the most interesting field for hackers. So that's why I'm focused a lot on building architecture, also doing some security assessment to it, design it, and also assessment of implementation. I was a part of building a security feature to protect online payments in our company. I was the part of like architecture team and also a part of implementation team. So maybe not all of you know what N26 is. This is a European bank. We call us like banking, but without the bullshit. It's like our famous campaign in Germany. We're trying to reduce bureaucracy, and we're completely online. So we give our customers all the same features that all traditional bank gives, like opening account, card, savings, credit, overdraft, but everything they can do with their smartphone. So we are like a bank in the pocket. And currently, we have 1 million users across 17 countries in Europe. This is like all countries with euro currency. We speak to our customers in 5 different languages, and we're going to extend soon to UK and US markets. What are our competitive advantage? So we're a little bit different from traditional banking, and we using modern tech stack, and we don't have a lot of IT legacy because we're quite new. We're just like 4 years, but we still have monolith. Everybody starts with monolith. And when we started growing, in 9 months, we grew from 500,000 customers to 1 million. So we understood that we need to scale. And for scaling, we decided to move to cross-functional teams that, like, based on Conway's law. And currently, we have 15 cross-functional teams that are responsible for different domains. And we have about 60 plus responsible microservices that these teams are responsible for. This gives us opportunity, together with our setup, like deployment setup, to deploy more than 90 times per week in average. So we're the bank that is completely hosted in the cloud. So we're completely in Amazon. And this makes all audit and legacy authorities crazy, how to explain that all customers' data and transactions are stored in the cloud. Together with like our tech stack is backend is Java, currently is Kotlin, Spring Boot, we're using Docker, and a lot of HashiCorp technologies. This is how our CI/CD pipeline looks like. That gives us opportunity to deploy to build 900 builds per week on average. So our pipeline is also as a code. So we don't set up for every microservice a separate build in Jenkins. Everything is written as a code. And it's easy when we set up a new microservice to add any step, like end-to-end test, and then we will include to our pipeline running end-to-end tests on any environment, like dev, staging, live. And if there is some problem that our microservice goes, the pipeline will be blocked. So after all tests pass, we have like also security checks, unit tests, integration tests, etc. We are deploying to every environment step by step with blue-green deployment. So infrastructure as code. Yeah, our DevOps team is really a fan of HashiCorp, and we're using Nomad and SaltStack to deploy our services, and it's really easy to kill at any point and bootstrap a new service. For service discovery, we're using ColdSol. It's also from HashiCorp. We're also using it for leader election and configuration management, dynamic parameters of our app. And we're using Vault to store secrets. So we are making sure that nobody can have an access to unauthorized access to our secrets. We're also using containerization, Docker, so we can make sure that our code is consistent on all environments, dev, staging, live, and also it helps us to testing, so it's really easy to bootstrap up with any environment in on local machine. And yeah, everything is based on code, so all auto-scaling services, like all auto-scaling groups as code. So we're like using our service, treating our service as cattle, not pets. We have many pets in our office. We like them, but with services we are not petting a lot. So for of course, we're in distributed system, monitoring and logging is a big problem. And we need to collect logs and a lot of metrics of user requests, user actions, some weird behavior, thread holes, request time, response time. We're using many dashboards for this, and for logging, we're using ELK. So after logs from your from the instance go to Logstash, then it's pumped to Elastic, and then we can read and see what is going on with Kibana. And using this monitoring and logging, we can identify some anomalies in the system, some weird behavior. Also, like we're using this data for fraud protection. We love to experiment. So we are not this bank who is like, it works, don't touch it. No, we usually like to try new technologies. And with microservices, it's quite simple. Like also, we have these days that we call get stuff done days, where we can experiment with different technologies. And yes, as a bank, we have to parse different security stages to adapt some technologies on, especially on backend. And one of these was Kotlin. So we moved our backend to Kotlin step by step. We're not using it for every service. We're not mixing Java backend and Kotlin backend, but we started with testing. So once I was asked, like, if I'm working in a boring bank, how can I ask my management to start using Kotlin? So first step, like we asked to start using it in tests. So we just put it to our Maven, it was built, then we started writing tests in Kotlin, then some internal tools, then we chose some service that is not so critical for login or for some transaction and security, and we started using Kotlin there. And now Kotlin is completely adapted, and we can use it in live production services. So all of this gives us opportunity to build features quite quickly, and one of the features is 3DSecure. So probably most of you, while you were paying online, saw this special screen when you need to provide some password or some code that you received via SMS, or maybe some questions that you put while you were opening your bank account. So usually online, this is 3DSecure. So before it didn't exist, and fraud transactions were like super easy because the only you need is your card number, some expiration date, and 3 digits code, and it's easy to get, like when you're withdrawing money in not good ATM machine, it can be scammed, and then your card is in database where like any hacker can get access to, and then many websites where people can like use your card. So you're not protected to spend your fund without this online protection without authentication. So moving further with online payments to protect customers, Visa, MasterCard, and American Express, they understood that they need to put some layer to protect card online transaction, to give the same level of safety, the same as when you're paying offline. So first was Visa. They implemented a special protocol, and then this protocol was adopted by Mastercard and American Express. So this protocol is 3DSecure. This is free domain. So to give you the same level of security, 3 different domains are working together. What are these 3 domains? First one is your bank, who gave you the card. This is the domain who is responsible for authentication. This domain knows that you are you. And then the third domain when you are paying, so the bank where you want to send your money or some website. And the third domain that connects these two is like big payment system, Mastercard or Visa. And all these 3 domains working together and to protect use of your funds. So what are benefits of this feature? It protects cardholder against unauthorized use. It's super easy. Usually you don't need a special software. Only some banks give you like an additional app. And this is like increasing your confidence paying online. It's about 1 million different merchants across 122 countries. So it's really widely used. And this is for customers. It's also for online shops. It also gives them benefits like with increased confidence of users, more and more volumes of sales will be online. So, and also it migrates the risk from their side. So if they ask your bank to authenticate you, this means that you already authenticated. This risk is on the bank side, and merchants don't need to care about this. So how does it work? So on issuer domain, so on the bank that issued your card, that give you the card, virtual card, plastic card, there are 3 different components. Enrollment server, this component is responsible to register your card in this program. So sometimes you need to go to your bank and provide a document that you want this additional security layer for online payments. Sometimes it's together with issuing your card. And then as soon as you, like, for example, activate your card, this should be enabled. There is also access control server. This is most of banks outsources to license software companies, and this is responsible for authentication. It can be SMS code, it can be like some password, it can be some question, and voice call, and account holder authentication value domain. So usually when you're paying on some website, and they can ask you to authenticate a transaction for €1, but later they can create transaction for €100 and include your authentication signature to this request. So you authenticated the transaction for €1, but they created for €100, and this part of issuer domain should validate that signature is the same as you were authenticated, the transaction is the same, that it was not changed by on any time. So acquired domain, this is domain on the side of website, merchant. There is a merchant plugin that is like connecting to Mastercard to find how to authenticate the user, what to use. And there is also a signature validation server that is basically validating that transactions were really signed by you. So like it was really authenticated by you. And there is domain that the name I cannot pronounce. This is like usually Mastercard or Visa. This is between 2 domains. It connects these 2 domains. And directory server, it stores like what card belongs to what bank. So what bank is responsible, what company is responsible to authenticate all online payments for this card. And certificate authorities is responsible for generating all certificates and share it between all 3 domains. So later, user authentication can be checked. And there is also authentication history server. It's more like for legal issues, for refunds. This is like all history of all these authentications. So this is a schema how it works. So usually you're first going to some website, you want to buy something, and you're on merchant site. It's like acquire domain. So you chose something, you're going to proceed, then you need to provide your card number, expiration date, CVV, and then this using merchant plugin, website sends request to Mastercard to validate if your card is registered to this or not. Then if the bank is registered, then Mastercard sends request to this bank to issue a domain to validate if this exactly this card is registered currently, if it's not blocked and stuff. And if it's registered, issue a domain will return the URL that can be used to authenticate the user. This domain will be redirected back to acquired domain to merchant site, and on this site, merchant will redirect to this screen. And here is like when you paying online, you probably saw the screen of your bank with sometimes with a logo of your bank, where you need to provide some secret, some code. This is happening on issuer domain, and as soon as it's you fill and we validate the code, or like issuer domain validates the code, we're sending pair authentication request or response back to acquired domain. They're validating on their side that the transaction that was sent to issuer domain was authenticated, and then they're creating a transaction. And transaction will be also then sent to issuer domain, and there will be checked that the authentication and transaction are the same, so it was not changed at any point of time. How we implemented it. So we decided that we want to enroll all users automatically to Mastercard system, 3DSecure protocol. So every time when we link card to the user, even if it's just virtual card, we already register user to this system. We are using external ACS provider, TouchTag, that is licensed by Mastercard for user authentication. But we don't want to register user separately, so we're using always our register verified device for transaction confirmation. So we decided to use our standard certification mechanism that we're using for all actions that should be certified by user in our app, so we don't need to educate the user. And we don't challenge every transaction. So what does it mean? When you're paying, sometimes you're doing actions that are the same every day. So for example, you're paying for your ticket to metro or to bus by your card, online payment every day at 9. And we don't want you every time to do a special additional action. We know that you is you. So for this, we're using a risk model. Behind it's machine learning. So we train this risk model with your data, with your behavior. And we're trying to simplify your life, like when it's day-to-day behavior. And we always challenge you to confirm this transaction when it's something like something new that we don't know. But even if it's day-to-day, we always can ask you to confirm if we need just like to know that it's really you. So how it looks on our side. For me, I like to shopping a lot on Zalando. So Zalando is a merchant. After this, it sends requests to Mastercard. All our cards are enrolled to 3DSecure protocol. And then it sends requests to our ACS provider. Our ACS provider checks the risk model, calling us. And if this transaction is OK and we don't need any additional action to the user, we just say OK, and then transaction will be processed as before. But if we want to validate that user is user, we send a push notification to a paired device for verified device, and then we're waiting for confirmation from our user. And after confirmation, the transaction will be proceed on our side. So we took a look when we were building the architecture for this solution to all our microservices that have to be touched. And of course, we need a card service, we need some user service events, we need a certification service together with notification service to confirm the transaction. And we also needed, of course, some new microservices, and it was a special service for 3DSecure for integrating with our partner, and risk model that is like a stateless machine learning model. And for integrating with our partner, we're using two types of integration. One is integrated inside our application, mobile app. This is like their SDK, and we're using also backend-to-backend communication. We connecting to touch tag for every card enrollment when we want to register our card in this security protocol, and also our partner connects to us, and for this we have a special partner like API Gateway plus auth to JWS tokens, and it's used for two flows, like check transaction risk and also like confirmation of this of user's action. So for partner integration, we usually use API Gateway. We have separate two services, OAuth, that is only responsible for generating JWS tokens, and we have API Gateway that is responsible for checking that this token is a valid authentication, that is also a valid authorization, that this partner can have access to the target service. In this case, the touch tag can only connect to 3DSecure. And there is no communication between OAuth service and API Gateway. And we achieve it using two pairs of keys. So we generated two pairs of keys, and we are storing them in Vault. For authenticator, we are storing public key and private key from the second pair. And for API Gateway, we are storing encryption private key and for signing a public key. So what happens when we get a request from the partner with their ID and the secret? We are using authenticator to generate the JWS token. Inside of this token, we have a secret that we encrypted using the public key of authenticator. And also, we are signing this JWS token with a private key from authenticator. As soon as this request comes to API Gateway, first we check with our public key the signature. So we know, okay, this is signature from our authenticator, we can trust it. And then we decrypt the private key. Using private key, we decrypt a payload, and there will be some secret that is needed for authorization. So we can check that this was like really JWS token of the partner who can access this resource. So for enrolling card to Mastercard protocol, we listening to different events from our system. So after user sign up, there is also process of verifying our user. And after user verified, we are publishing an event to our Kinesis event stream. And then card is linked and issued to the user. And then at this moment, we're publishing an event that is one of listeners is a 3DSecure service. So as soon as we get an event that card was linked to the user, that card was sent to the user, we're registering card, like connecting to touch tag and Mastercard. So this card is protected by this protocol. For events, we're using Amazon Kinesis, and we're using protobuf. We have one event Kinesis stream along all our services. So all services are publishing to one Kinesis stream, and all services are listening it. And for this, we're using also shared libraries for producing events and for consuming events. And also protobuf gives us opportunity that we can use these classes generated for every language. So if we have some microservices that are in Python, that are sometimes in Node.js, so when teams are playing, they still can listen for this event. This is an example of protobuf event. For example, we're interested in event of locale changed, that user changed the language, and we need to show authentication page in different language. So this event we're listening in 3DSecure service. So there is, after sign up, we have a step of pairing device. So we believe that you always everywhere with one of your smartphones, and we want, because we don't have any branches and we don't have any offices, and this means you cannot, to confirm your actions, we need something that really belongs to you, and using some secrets and that you only know during the registration, and also sending a code to your phone number, we can pair your device to you. So we can say that this device is verified, and any action from this device, we believe that it's trusted, that it's secured, that it's you. Of course, there is some unpair procedure. If you, for example, lost your phone, there are even more security steps that you have to do, but it's still possible to change your paired device. And because with using several steps, it's most probably nobody else can pair the device to them. So it's your card token secret, some information from your password. Also, you need to be able to log into the app. So there are several steps. So after the device paired, from this device, we are generating the pair of keys, and we are sending the public key to backend, and private key is stored on front end. And then we are using this for example, for signing every action that happened from this device. So, for example, if it's iPhone, you can create Siri transaction only from this one device. So every time when you're creating a Siri transaction, we are signing this transaction using the private key. And then on backend, we are verifying the signature using public key. Also, this pair is used to share the secrets between front end and backend. There are some secrets for registration in system, for example, in 3DSecure, that we don't want to send you in a plain text. There are some passwords that we don't want to send you in a plain text. So what we are doing, we are using this public key to encrypt the secret on backend side, and then any device can fetch this from the backend, but only the device that has a private key can decrypt it. And after that, they can use it. So if you don't have any registered device, you cannot do any actions that are waiting for your confirmation. So for registration on TouchTag and Mastercard for this 3DSecure protocol, we need to share some secret from backend, some one-time code, and card token from backend to registration device, and then registered device, and then this device should send it to TouchTag already decrypted using SDK, and so we're using private public key from that device. So risk model, as I mentioned before, we don't want to challenge every transaction. So that's why we're when we get metadata from merchant, we also have some user behavior, and we have some fraudulent behavior. We're looking on amount of transaction. We're looking how often do you create transaction, how often do you pay online, how often do you pay with your card offline, and many other different behavior from the user can influence the decision to be accepted, declined, or challenge the user. So this is how the transaction accepted flows looks like. So when user tries to pay online, it goes from merchant to TouchTag, and TouchTag, our ACS partner, calls through API gateway our 3DSecure service, we check risk model, and if it's secure transaction enough, we say accept, and the user even won't see the screen to provide some code or anything else. Oops. And if we if we want to challenge transaction, then we return to touch tag that we need to wait for user confirmation. At the same time, using SNS, we are sending push to registered user device. Device will fetch information to display a pop-up for confirmation inside the app. So from merchant page, you will see that you need to go back to your application. You need to log into N26 account. So it's like one secret. And then after you logged in, you should be logged into your verified device. So it's like the second secret. And then you can confirm this request will be signed, and we will validate the signature on backend side. And then this can be confirmed also on Mastercard side, and we will send this authentication signature back to merchant. So sometimes it looks like this. So for example, my German bank sent me my card in 4 different mails. First was a code to get to my web app, then to my application, and then I received these codes. So every time when I need to pay online, they ask me to provide code number 67. And of course, if I don't have this paper with me, I usually don't, I cannot pay online. And also, yeah, this drops conversion, and not many websites wants to use these codes. And they sometimes don't even ask for authentication because they want to sell, and they can take risk that this is not you. Also, the next step is one-time password. So most probably this page you already saw. And so here, usually some online shops asking for some passwords. Sometimes there is no even your bank logo. So why it's tricky? Because here can be some phishing site, and someone can show you this screen and to verify another transaction. So you can provide the code, but it's not your bank. Also with SMS, like with secret, it's even worse, because if it's not one-time password, but if it's your secret for the whole your bank application, it means once you provided this on a bad website, this password is known to hackers and they can use, so they know your secret. But if it's one-time password, it's much safer, but there are like problems with SMS already were announced that SMS two-factor authentication is not secure. So it was several messages from different companies that SMS were hacked. So there is an opportunity to intercept and receive your SMS codes and then to authenticate your transactions. For example, there was one app on Android that were creating transactions. At the same time, it was listening for SMS, and then it was providing the SMS code. So basically, transaction was authenticated by this virus on your phone. So yeah, there are like many articles about why better to go away from SMS-based authentication. Yeah, from our side, how it looks like. So on the merchant channel, when you're paying, you see the page with amount, with a timer, how fast you should go, and then you need to go to the app, or like also this is when you're paying from the app. Inside the app, you will see your usual push notification, and it's only on your paired device. And then there is a list of these events, and then you can choose what you want to confirm. And then there is a pop-up. After you press the button, confirm payment, device signing this response from you, this action, together with a payload that was sent. So like here, we're verifying that device is like signing exactly what you show to the user. So if you show to the user 1,500 euros, this will be included to the signature of this response, and then it sends to backend. And yeah, thank you. And if you have some questions, you can ask me. That was first, sorry. So, like from Mastercard point of view, we are close to 3DSecure 0.2 because it's like inside the app there is a problem that like it's SMS code you cannot receive. Well, for example, you're traveling and you need to exchange, and they want like to connect it more like backend to backend because it was more first. So I think in 2019 it should be standard, and new banks should start implementing 3DS 2.0. But it's not yet official. So yeah, we are close to it. It was like homemade 2.0. So and also like this risk model, the idea from Mastercard and Visa to use to challenge less and less transactions. So like to make risk models smarter. So less users will like do this action when they don't need to do. So in this case, it was requirement from Mastercard to do this risk model to challenge less users. Yeah.
Based on your experience and knowledge about this Visa Mastercard system, do you think it will be a big effort to implement the Visa Amex solution in your application?
There are like from our domain as a access control server. No, because we're using this license partner, so we just need to integrate with Visa regarding payments authorization. So like 3DSecure is a standard, but it's also like different. So for example, for merchant, there are like different even requests. So like for example, to validate if card is registered to Visa or to Mastercard, you need to send different requests. They're similar, but still like different field names, and yeah, so there are some difference. It's a protocol. It's like means that like signing is similar. There are like similar answers, so it gives you a URL from the bank, but it's still like different names, different URLs, different certificates, and also different license. So for every single payment system, you need to get your own license. So if you're authorized to do this authentication with Mastercard, it doesn't give you like that tomorrow you can do the same with Visa. No, it's like a long process. Yep.
So, from what I understand, this process of trusting the device and pairing the device is like verifying some information, and based on information, you believe that this device belongs to this identity, and then you start creating this key pair and share the public key with the server and like maintain it. So do you think that there might be a chance for some other application on the same mobile device to have access to the private key?
I believe that it cannot, because we're like taking care about this private key storage. Yeah, on server side we're storing public keys. That is not scary. But on mobile, yes, we're storing private keys. That is that shouldn't be accepted.
Okay, so one other question for this process of verifying the transaction, you mentioned that you probably provide some information in the signature, which I believe is the digital web copy for just 3D authentication.
You mean when we connect partners, or when we share secret from backend to frontend?
Yeah, for the 3D secure step.
Mm-hmm.
I'm not sure if I understood correctly.
Mm-hmm.
You use this pair in general for this web token, and you put some information in the token
Yep.
payload, like the transaction amount and the currency. So at least for the 3D secure, you validate this.
Yeah. Yeah, it's not only for 3DSecure, it's also like for all outgoing transactions, or even any action. So basically, how it's happening when you see this pop-up, there is like some information about transaction. Yes, so there is a merchant that we know, there is an amount, there is a date, and maybe there is something that we like everything that is shown to the user is inside the payload, and then when we send back like action, we put it together with all this data and we sign it, and on backend we store the initial payload, and we get like accepted, for example, and this signature, and we are validating based on this signature and the initial payload. So we always store this payload and everything that was like the whole payload that was shared with devices signed. Yeah, yeah. And action, of course, because you can, yeah. Yeah.
Two questions on my side. Number one, did I get it right that there is the option of authenticating with the fingerprint?
I think it's confused because our partner is using this fingerprint as a logger. Yeah, so like you can use this when you log into the app. Yes, we're using fingerprint on this level, but for now we're not using it as authentication of transaction. But it's one of like use cases that we want like to investigate later.
I wanted to know because this would be very, very tricky with the European Union laws, the GDPR, because this is not like your password. This is also personal identification information, and
Yeah.
it's quite a headache. So I wanted to know.
Yeah, we investigated because it's also like can be like going away from SMS codes, and fingerprint can be a nice secret that can like that only you can have. Yeah, well, like one off, yes, and then maybe confirmation will start using this, but for now it's only for login. You can log in, or like some template, I don't know, Android.
The second question is, I mean, I come from the fintech industry, and we all know in the fintech industry the famous YouTube videos about in 26 years ago.
Yeah.
My money.
Yeah.
How did you go through the transformation from having famous YouTube videos showing how to hack the app to the level where you are now?
Yeah, so after, like, this was a stage of startup. We were not even a bank when it happened. Like, before it was, like, maybe not of you know, there was a company number 26, and there were, like, it's our startup, yes, and based on Wirecard, it was our partner, all card processing, all transaction processing were right there. There was, like, a video from Vincent about some security vulnerabilities that were found in the app. And this year was announced for us, like it was the same year when I joined, that like security now is priority. So we're not only delivering features first, but we need, like, we're working with money. And also this time when we got the license, it means that all processing of transactions and cards were moved from Wirecard to our new infrastructure. So this this is a new code, and currently security is a higher priority in the company. Yep.
Just one inspiring about another one question about the risk that you are making, so you don't have to challenge every transaction as you mentioned.
Yep.
So you still need to store some information about the user, you know.
Yep.
I mean, you track the user somehow. I'm not sure how you find some issues with the GDPR in general, and I'm not sure if you are actually using like external risk management.
I think we're using for already, like, when the layer of payment, like when authorization comes, like when it's already after authentication step, but I don't know exactly because I'm not in this team. But about, yes, we're storing, of course, like all history data, like all users' behavior, but like the model is stateless. We don't have there, but we like have the data across the company, like in different microservices. We have users' behavior saved. From GDPR, yeah, like I'm also not working with this, so but I mean, with the request, we can remove this data. Yes, it's like, or we can provide this data to the user. So this is like, we're storing like actions, how often user plays, so all transactions we have to store. So based on this transaction, we also can make some decisions on risk model side. So even like from your transaction history.
So you are doing it on your side, not sending the data to someone?
No, no.
You told us that 90 deployments per week, I think, which is very fast.
Yeah. So everything is deployed automatically. There are like no manual processes. It's possible, for example, if we really need some like regression testing on some component, we can disable it. It's also like a code because our pipeline is basically a file inside of every microservice. So basically, you can disable, for example, live deployment, and this means that pipeline will stop on the stage of staging deployment end-to-end tests, and then you're like testing, for example, and next you enable it again and you deploy. So also it's nice because for us it's history, and like if it's inside your repo, so your pipeline also inside your repo, nobody can deploy without you to live. So if you disabled live deployment, only your team can enable it again. So there is a flag inside your pipeline, live deploy, yes, no. If yes, we go to live. If no, we stop on staging. Yeah. So seems like no questions more. Thank you. Thank you for coming.